Welcome to a lesson with Dr. Powell. Let's take a look at solving a system of equations in two unknowns. Now, what does this mean? This means we're looking for a pair, x comma y, or maybe multiple pairs, um, such that both of these equations are satisfied by these pairs. One way of thinking about that is graphically. The top equation actually, through rearranging, is y equals x squared, just a parabola. The bottom equation is a circle with radius square root of 2. Now notice that there are two different intersection points, as we just roughly sketched this, so we can expect there to be two different solutions. These intersection points are precisely the solutions to the to the system of equations. So we could do this graphically, even on a computer or device, and be able to pinpoint. The device can help us actually pinpoint what those intersections are. However, we're going to work through this algebraically here, and the technique that we're going to use is substitute. We're going to look at expressions that appear to be the same in both from one equation to the other and work with that. How do we do that? Well, notice that we have an x squared that looks the same in both equations. So what if we were to solve for this x squared, this top equation? It's equal to y. X squared is y. So that means that in this bottom equation, we can simply just replace this y in for that, because we're assuming that both of these equations hold true. So we're assuming that x squared is y. Under that assumption, this equation right here takes on the form y plus y squared is equal to 2, just substituting this x squared for y. Okay, so now we just need to figure out what y's make this work. Well, to do that, this is a quadratic equation. Notice I have a y squared and a y. We should move everything to the same side. So we just have 0 over here. Rearrange y squared plus y minus 2. We can factor this y, then we have a minus, minus 1 and a plus 2 should work. So that means that y is either equal to 1 or y is equal to negative 2. And we go ahead and for each one of these particular cases, we plug in and see what happens. We try to see what x should be in each one of these cases. Oftentimes it's nice to use something that's rather simple. Notice how this right here has into one of these equations. This one has y solved for, and x is ready to find out. In fact, x should just be the square root of whatever y is. So let's use this equation here to figure out which x values apply for each one of these y's. So for this one, y equals 1. Let's see. This means that x squared would be 1. So that means that x should be, now when we take a square root in an equation, we always take a plus or minus. So it's just plus or minus 1. That means for this one y value, so let's see, for this one y value, so we have a y value of 1, x can either be plus 1, or again for this y value, or negative 1. So we have two ordered pairs corresponding to this. Now we were expecting two solutions. So what do you think will happen with this guy? Y equals negative 2. Well, let's plug in negative 2 into this equation here. We see x squared is equal to negative 2. Now we say x is equal to plus or minus the square root of negative 2. Now in solving this system of equations, we're actually only looking for real valued solutions. Oftentimes that's kind of the goal here. So therefore we just cross these out and say, well, that was a bad choice. So really, we have two solutions just as expected. Thanks for watching.